This is Cambridge IGCSE International Mathematics, October November 2020, 0607, paper 61. So the first one is investigation and investigation. Question number 1 and 2, piling square, 30 marks for 50 marks. This investigation looks at different ways of piling squares. Squares are piled in the pattern like this: one square, then two squares in the bottom row, so totally three squares. Then next, three squares in the bottom row, then two squares and one square, so totally six squares. On a dotty paper, complete the next diagram of this sequence. So therefore, over here four squares are there. So what should I be doing it out? I should be drawing it out three more squares on the top of it. So, okay, one, this is a one square, then the second square, then the third square. Then on the top of it, again two more squares, first square and the second square. Then on the top of it, one more square, first square and that's it, first square. Complete the next diagram, we have done that. Next, complete the table. Number of squares in the bottom row 1, total number of squares is 1. If the number of squares are 2, it is total is 3. If there are 3, it is 6. And if there are 4, it's going to be 10. So see the pattern. What is going to be the pattern? We can see that the difference is 2, the difference is 3, the difference is 4, the difference has to be 5, 15, the difference has to be 6, which is 21, the difference has to be 7, which is 28. A formula is given for finding the total number of squares is t equals to x square plus ys. Find the values of x and y. So for that, what should I be doing it out? I should be using the values from the table t and s. So I take it out. T equals to 1 and s equals to 1, x times 1 square plus y times s. So what do I get it out? X plus y equals to 1. The next one, I take t equals to 3 and s equals to 2, 2 square plus y times 2. So I get it out 4y plus 2y, 4x, 4x 4x plus 2y equals to 3. So I got these two equations, solve these two equations. So multiply this equation with 2 and subtract from the second equation. So 4x plus 2y equals to 3 is the second equation. 2x plus 2y equals to 2 is the first equation. Subtract both. When I subtract both, minus minus minus, 2y 2y cancels, 2x equals to 1, x equals to 1 upon 2. Once I get x equals to 1 upon 2, plug in that x equals to 1 upon 2 over here. 1 upon 2 plus y equals to 1. Y is also equals to 1 upon 2. Show that the formula in part 2 gives the correct total for a pattern of squares with 8 squares in the bottom row. 8 squares is nothing but what? When we see add 8, it should become 36. So t equals to 1 upon 2 x s square plus 1 upon 2 s. That was the formula. So now it should be 8. 1 upon 2 times 8 square plus 1 upon 2 times 8. So 64 upon 2 plus 8 upon 2 is 4, which is 32 plus 4, which is 36. Have we got 36 over there? Yes, we got 36. So therefore it is correct. Black squares and white squares are now piled on top of each other. Every row starts with a white square, followed by a black square, followed by a white square, and so on. It is the same way. Then what is he asking now? Fill the next term. So what am I doing it out? Next square. So first there are 4, so there should be 3 on the top of it. Then but that 3 should be starting from the, like last time, it should be starting from the one line. So therefore we erase it out over here and draw from here. 3 should come 3. This is the first square, second square being drawn, and the third square being drawn. Later I'll shade with black and white. Then first square and the second square, and there should be only one square. And alternatively black and white. Starts with the white, then goes with the black. So therefore, this one goes with the black. Starts with the white and goes with the black. Then white starts with the white and goes with the black. This is the one, it has been done. Next, he is asking us to fill the table. 4 black, and how many white are there? 1, 1, 2, 3, 4, 5, 6 black are there, and 6 white are there, and totally how many do we have? 10 we have. So now we have to fill for bottom row 5 and bottom row 7. So what is the pattern? We can see that. We can see that, see, number of white squares becomes the black squares in the next one. Number of white squares becomes the black squares in the next one. So number of white squares will become the black squares in the next one. So it is going to be 6. Now 6 plus 9 is 15. So you can see that 9 and 9. So this has to be nothing but over here 12. And 12 plus 16 is nothing but what? 28. So number of white squares in the previous one becomes the number of the black squares in the next one. Next, complete these two tables of the black squares. Some of the information is given, some of the information is in the table part B. Odd number of squares on the bottom row, 1, 3, 5, 7, 9. Number of black squares. So, odd number 1, 3, 5, 7. Number of black squares. We can see that it is 0, 2, 6, 12, 20. Number of white square, number of, then for even number. For even number, it is going to be 1, 4, 9, 16. So you can see that it is a perfect squares. 1 square, 2 square, 3 square, 4 square is to be 5 square, which is 25. A formula for finding the number of black squares when the number of squares on the bottom row is an odd number is this one. Find the value of x and y. So this is for an odd number. So B is the number of black square, S is the number of squares in the bottom row. So what am I going to do it out? I am going to take it out B as 0, the first one 0 and 1. So 0 equals to 1 times S square plus Y. 0 equals to X times 1 square plus Y. So X plus Y equals to 0. Then next I am going to take it out 3 and 2. So B is 2 and S is 3. 3 square plus y. So 9x plus y equals to 2. Subtract these two equations. 9x plus y equals to 2. X plus y equals to 0. Then subtract 8x equals to 2. So x equals to 2 upon 8, which is 1 upon 4. If x is 1 upon 4, y is minus 1 upon 4, because x plus y equals to 0. Find a formula for the number of black squares when it is even. When the number of squares on the bottom row of S is an even number. So we have to find it out a even number. Even number, just now we could able to say that this is 1 square, 2 square, 3 square, 4 square and 5 square. So it has to be related with this 2, 4, 6, 8, 10. So it can be clearly seen that S upon 2 whole square. Next, complete the two tables for white squares for the same information. So when we see from that one, 1, 3, it is 1, 4, 9, 16, 25, and number of white square, it should be, what is this, 2, 6, 12, 20. So how should it be that? What should be the pattern over here? We can see that the pattern is, the addition is 4, addition is 6, addition is 8, so it has to be 10, so it becomes 30. Now the formula is W equal to xx square plus ys plus 1 upon 4. Find the value of x and y. A formula for finding the white squares when it is odd number. So I take 1 and 1. W is 1. S is 1. So from there I get x plus y equals to 3 upon 4. Next time I am going to take 3 and 4. W is 4. S is 3. S is 3. So 9x plus 3y equals to 4 minus 1 upon 4 is 15 upon 4. Now multiply the first equation with 3 and subtract from the second. 9x plus 3y equals to 15 upon 4. Then 3x plus 3y equals to 9 upon 4. Subtract it out. 6x equals to 6 upon 4. X equals to 1 upon 4. Once I get x equals to 1 upon 4, 1 upon 4 plus y equals to 3 upon 4, y equals to 2 upon 4, which is 1 upon 2. So 1 upon 4, 1 upon 2. Find a formula for the number of white squares when the squares on the bottom row is even number. So even number. So what you have to do? You have to relate for 2 to 4, 4 to 6, this one. And when we see the second differences is nothing but what? 2. The second differences are same. If the second differences are same, it is going to be nothing but what? In the form of an square plus bn plus c. So an square plus bn plus c. So therefore, what am I going to do it out? Take the first values, s equals to 2, w equals to 2. S equals to 2, w equals to 2. So I have to get it out the value of s equals to 2 and w equals to 2. So w equals to an square plus bn plus c, but because it is s and this one, so I replace n with s, nth term. If at all the second differences are same, we are going to use an square plus bn plus c, but instead of n, it is nothing but what? S. As square plus bs plus c, and w equals to. So 2 equals to a times 4 plus b times 2 plus c. So I get 4a plus 2b plus c equals to 2. Then next value 4 6 and 6 12. S equals to 4, w equals to 6. So what does do I get it out? 6 equals to 16a plus 4b plus c. Next one 6 12. S equals to 6, w equals to 12. 12 equals to 36a plus 6b plus c. So I got three equations. I got three equations. Let me make a proper arrangement. These are the three equations I got it by substituting the values of s and w. Now what am I going to do it out? I am going to solve these two equations, subtract these two equations. So it becomes 12a plus 2b equals to, what is this? 6 minus 2 is 4. So divide by that, we will later divide by 2, or now only we can divide by 2. 6a plus b equals to 2. Then again subtract these two equations. So what does it becomes? 20a plus 2b equals to 6. So it becomes 10a 10a plus b equals to 3. Subtract these two equations. Negative 4a equals to negative 1. So a equals to 1 upon 4. So I got the value of a equals to 1 upon 4. Plug in the value of a equals to 1 upon 4. So it becomes 6 upon 4 plus b equals to 2. B equals to 2 minus 3 upon 2. So b equals to 1 upon 2. So I got b value is 1 upon 2. Now plug in 4 times 1 upon 4 plus 2 times 1 upon 2 plus c equals to 2. 1 plus 1 plus c equals to 2, so c equals to 0. So finally my answer is going to be 1 upon 4 s square plus 1 upon 2 s. Coming to party, the pattern has 253 squares. So total number of squares formula is 1 upon 2 s square plus 1 upon 2 s. This is 253. 253 equals to 1 upon 2 s square plus 1 upon 2 s. So s square plus s equals to 506. So s square plus s minus 506 equals to 0. So now what am I going to do with it? I'm going to factorize this one. So when I'm going to factorize this one, it is s minus 22 times s plus 23 equals to 0. So s equals to either 22 or negative 23. Negative 23 is not considered because number of squares cannot be negative. So it is going to be 22. So total number of squares is going to be 22. Now 22 is an even number. So number of white squares. So number of white squares, if at all it is an even number. So find a formula for number of white squares if the number of squares at the bottom is even number. This is a formula 1 upon 4 s square plus 1 upon 4 s. 1 upon 4 s square plus 1 upon 2 times s. So take that one, 22 square divided by 4, then plus 11, it should be equals to 132. Now total number of squares is 253 minus 132. It should be 121. That's going to be the answer. Coming to question number B, it is about a bouncing ball. Now he says that a ball is dropping from 10 meters and it is rising to a maximum height of 5 meters or half to the previously dropped. So 10 became 5, 5 becomes 2.5, 2.5 becomes 1.25, and in the fourth bounce is being asked, it becomes 0.625. So it will become 0.625 in the fourth bounce, which is nothing but what? 62.5 centimeters. What is he asking in the next part? Calculate the first maximum height less than 10 centimeters. So once again, when we start writing from there, 10, 10, 5, 2.5, 1.25, 0.625, then 0.625 divided by 2, which is nothing but what? 0.3125, then divided by 2, which is 0.15625, which is again divided by 2, it becomes 0.078125. This is less than 10 centimeters because this becomes 7.8 centimeters. So these are all in meters, so he's asking into centimeters. So therefore first bounce, second bounce, third bounce. So answer for this one is 7.8 centimeters. But in the next one, he's asking it out how many times it has to bounce. So 4, first bounce. So over here, this is the first bounce, second, third, fourth, fifth, sixth, seventh bounce. So it became seventh bounce less than 10 centimeters. Next, what is he asking in the next one? Is he asking us to find it out? He is asking us to a model for the maximum height which the ball rises after the bounces is given over here, where for example when n equals to 1, h equals to 5. Find the values of p and q. So n equals to 1, h is 5. 5 equals to p times q to the power of 1. So 5 equals to pq. We got it on that one. Now n equals to 2. Second bounce, we know that the height was nothing but what? 2.5. So 2.5 equals to p times q to the power of 2. So now I got two equations, so start to divide them. So pq square upon pq equals to 2.5 divided by 5. So q equals to 1 upon 2. Once I get q equals to 1 upon 2, plug in over here, 5 equals to p upon 2. P equals to 10. P equals to 10, q equals to 1 upon 2. A ball drops from a height of 35 meters. After 4 bounces, it reaches to a maximum height of 0.056. Each time it bounces, it rises to a maximum height, which is a fraction of the height of the previous one. So 35 is the initial height. which is nothing but what? Our P. The fraction we don't know. And after how much, after n number of bounces, how much it is that? It is going to be 0.056. We have to calculate how many times, and 4. N is going to be nothing but what? 4. And we have to calculate what is that fraction is. So 0.056 equals to 35 times that fraction we don't know whole to the power of 4, because from last time we have known this one. So h equals to p times 10 times 1 upon 2 whole to the power of n. So we know that 10 was the initial starting height and it is rising half of the height every time. So and n is the number of bounces and h is the maximum height. Based on the same thing, h is the height, it has risen, and starting one is 35, and what is a fraction we don't know, and how many times it has risen or it has bounced 4 times. So 0.056 is equal to 35 times q to the power of 4. So q power 4 equals to 0.056 upon 35. So q equals to 4th root of 0.056 upon 35. Do that one by the calculator. You should be able to get it out 0.2, so which is 1 upon 5. Coming to question number 5, a model for the total distance d meters which ball travels vertically is given by this formula. He is asking where p is the height, q is a fraction of the previous maximum height when q equals to 0. So there is no fraction at all. Means what is it happening it out when q equals to 0? If q equals to 0, the thing is it will not bounce only. So the total distance traveled will be p itself only because it is not bouncing. There is no fraction. Q is 0 means there is no fraction. It does not bounces to the any particular part of the maximum height. Means the ball does not bounce. The ball does not bounce. Now when q equals to 1 means it is bouncing to the same height. The ball bounces to the same height. Next, the total distance of the ball in question 3 travels vertically. Calculate the total distance of the ball. In question 3 it travels. So what was the total distance in this one question 3? It was half of the height. So q equals to nothing but what? Half. So I'm going to use d equals to 10 times 1 plus half divided by 1 minus half. Simplify that, it should become 30. A ball drops from a height of 40 meters. The ball travels a total distance of 200. Each time it rises to a maximum height, which is a fraction of the height of the previously dropped. Calculate this fraction. So we know the formula d equals to p times 1 plus q upon 1 minus q. So d equals to nothing but how much? Total distance it has traveled is 200. It is dropping from 40. 1 plus q upon 1 minus q. So 40 times 1, 40 times 5. Cross multiplication, 5 times 1 minus q equals to 1 plus q. 5 minus 5q equals to 1 plus q. 4 equals to 6q. Q equals to 4 upon 6, which is 2 upon 3. The ball drops from a height of 10 meters. Each time it bounces, it rises to a maximum height which is half of its height previously dropped. Time is measured in seconds. The model is given by this formula, where q is a fraction of the previous maximum height. Show that t1 equals to 10 upon 7. So n equals to 1. So n equals to 1, 10 upon 7 times 1 plus square root of 0.5 minus 2 square root of 0.5 divided by 1 minus square root of 0.5, because for the first time it was half. So we can see that it becomes 10 upon 7, 1 minus square root of 0.5 divided by 1 minus square root of 0.5. Both are same cancel, so answer is 10 upon 7. Show that the time taken for the 10th bounce is 8 seconds. Correct two significant figures. 10th bounce. So 10 upon 7 times 1 plus square root of 0.5 minus 2 square root of 0.5 whole to the power of 10 divided by 1 minus square root of 0.5. Simplify that, you should be getting it out 8.02. A model T for the total time that the ball bounces is given. Calculate the total time that the ball bounces. So 10 upon 7 times 1 plus square root of 0.5 divided by 1 minus square root of 0.5. Simplify that, you should be getting it out 8.32. Sketch the graph of the model T in the part B. Q lies between 0 to 1. So when you draw it out the graph, so I am approximately drawing the graph. It should be in this proper way. You should be getting it out in this way. Part D, the time taken until the first box T1 is also modeled by this formula where P is the initial height that the ball is dropped from. Find the value of T where the ball is dropped from a height of 22.5. So just substitute 22.5, 2 times 22.5 divided by 9.8. Simplify that, it's going to be 15 by 7. So T1 is going to be nothing but what? 15 upon 7. Calculate the model for the total time T. Total time T formula is nothing but what? T equals to 10 upon 7 times 1 plus square root q by 1 minus square root q. What is this 10 upon 7? 10 upon 7 is nothing but what? When T1 is 10 upon 7. So over here T1 we got it as 15 upon 7. So our formula will be 15 upon 7 plus, times 1 plus square root of q upon 1 minus square root of q. If T1 was 10 upon 7, the formula for the total time was 10 upon 7, 1 plus square root of q upon 1 minus square root of q. Now, but T1 is nothing but what? 15 upon 7. So the formula will be changing accordingly. So that completes the paper. See you in the next paper. Bye.